Alright, so let's go through this question. We have this figure showing a y equal to negative 2x squared plus bx plus c graph, right? So part A, they ask us to show the area of the rectangle given by half BC unit square. Okay, so first thing first, let's determine the coordinate of R. So the coordinate of R is actually the y-intercept. So because you can see, right, the graph passes through the y-axis, hence I can simply just sub x equal to 0. Because y-intercept is x equal to 0, so you simply just put y equal to negative 2, 0 plus b, 0 plus c. So this tells me that the coordinate of R is 0, comma c. Okay, the next thing is, okay, before I talk about coordinate q, we know that the so-called the breadth of your rectangle is given by c already. Okay, so the next thing I want to do is to find what is this length, because the area of rectangle is length and breadth, right? Okay, so in order to find the length, I need to determine what is my q, and to determine the q, I need the x coordinate of q, because as long as I know what is the x coordinate of q, right, I can simply just determine what is this length. Okay, so the question is, I do not know the x coordinate of q, but I know the y coordinate of q. The y coordinate of q is actually equal to c. Why is it equal to c? Because they are the same height, or they are at the same level. So what I need is to sub c into here. Alright? Okay, so let's go to step number 2. Y equal to negative 2x squared plus bx plus c. So you simply just sub c into here to find the x coordinate of your q. So okay, c equal to negative 2x squared plus bx plus c. Then you move this, you move everything here to the left hand side. Then you move this to the right hand side. So what you get is positive, because you move to the left hand side, 2x squared minus bx equal to 0. So you can see, right, I want to solve the x. I simply just put x, factorize of x, 2x minus b, and put a bracket equal to 0. So my x is equal to 0, or my x is equal to half b. Okay, so apparently, if you look at q, my x coordinate of q cannot be 0, because 0 is right here. So my x coordinate of q must be half b. So now I know what is my x coordinate. So from R all the way to q, right, the length is half b. So now I know already. Okay, so now I know length, I know breadth. So half length times breadth, half b times c is equal to half bc. So that's how I solve part A. Okay, so moving on to part BI, right? So if the curve passes through negative 1 to 2, 5, find the value of b and c. So this one is still not too bad, it's still rather simple. Okay, they tell us that for the curve, right, you pass through negative 1, 2. Okay, negative 1, 2, okay, I say it's maybe roughly here. So this is negative 1, 2. Then after that, I pass through 2, 5. Okay, 2, 5, let's say is here. Okay, so how do I find, based on this information, right, how do I find B and C? As long as your curve or graph passes through these two coordinates, you can simply sub in the values inside your equation. Okay, so let's sub in the values first. For part B, so first thing, y equal to negative 2x squared plus bx plus c. So you sub in the first coordinate first. So negative 1, 2, right? Okay, always remember, first number x, second number y. So you sub in 2 here, equal to negative 2, negative 1 square plus b, negative 1, and plus c, right? Okay, so next, continue on. So this is negative 2 minus b plus C. Okay, so before I move on, just make sure that you know negative 1 bracket whole thing square is positive 1. Then negative 2 times 1 is negative 2. So after that, you simply manipulate a bit, right? Okay, so these two things you bring to the left hand side. So B minus C equal to, okay, this one you move to the right hand side. So negative 2 minus 2 minus 4. So what you get is B minus C equal to minus 4, which is first equation. So when you see me write this kind of thing, you know what I'm going to do already. Right? So I'm going to do the simultaneous equation. So, okay, next will be the 2, 5. Okay, let's write down. Okay, let's sub in the 2, 5 into the equation. So, y negative 2x squared plus bx plus c. So, okay, 5 and 2. So, this is 5, 2 sub in. 2 sub in. So, 5 equal to negative 2, 2 square plus 2b plus c. So left hand side 5. So 4 times negative 2 minus 8 plus 2b plus c. Okay, so now I move minus 8 to the left hand side. So it's equal to 5 plus 8 is 13. Negative 2b plus c. So now you can see, right? Equation 2 is out. So I make it into this. So it's nicer lah. Okay, so equation 2 I put here. So this one just erase first. Okay, so you can see, right? Equation 1 given like that. Equation 2 given like that, right? Okay, so I use the elimination method. So means that I use equation 1, you add on with equation 2. So what you get is, okay, left this b minus c plus 2b plus c. So what you get is 3b. Because the minus c plus c is gone already. So you look at the right hand side, negative 4 plus 13. So it's equal to positive 9. So 1b is equal to positive 3. It's out already. One number is out, means second number will be out. So now you go back to equation 1, right? So b equal to 3. So b minus c equal to minus 4. So this will be positive 3. So you just manipulate to find your c. So okay, 3 move to the right hand side, minus 7. C is equal to positive 7. So b equal to 3, c equal to positive 7. So that's how you do part bi. So part bi is about substituting in the values and get a pair of simultaneous to solve for two variables b and c. Okay, next part, let's see what they want. Okay, part 2. Hence, find the equation of the line that passes through R. So they want, okay, so I erase first. So, and it's parallel to the line OQ. Okay, so let's take a look at this word equation of the line. So when we want to write down the equation of line, the general form is always y equal to mx plus c. So mx plus c just means that I need to give them the m and the c. As long as I give them the m and the c, mc, I will get the full credit already. So what is m? M just means gradient, c just means what intercept. But the question is, how do I find... Okay, let's determine a gradient first. Okay, in order to find a gradient, you need to look at the last statement. So they say that, the line is parallel to the line OQ. So OQ, right? So let's draw the line OQ. So let's draw. Okay, so we know that, okay, Q is a... Okay, C, right? Okay, so I need the two values. So 3 and 7. So my equation is y equal to negative 2x squared plus 3 and 7. Okay, 3x plus 7. Okay, so just now according to my memory, so the coordinate of Q is C. So this is half B and C. Okay, half B and C. Okay, so we know that, my C is 7, my B is half. Okay, my B is 3, right? So it's just 1.5. Right? Okay, so given the idea here, right? So can I find what is the gradient of OQ? Definitely can, because I got two coordinate, right? So first, I know, oh, what is this? 0, 0. I know my coordinate of Q, 1.5 and 7. So I use y2 minus y1. So the gradient, I erase this first. Okay, the gradient of OQ is equal to 7 minus 0 over 1.5 minus 0. So let's determine 7 divided by... Okay, so the gradient of OQ is 4 to third. So since my so-called unknown line is parallel to this OQ, right, means that I must also be, the gradient of the unknown line must also be 4 to third. Okay, so next they say that, oh, this line also passes through R, right? Okay, I draw this line. Okay, so this line passes through R. So what's the point of, of giving us this information? Because remember, I got the M already, 4 to third. I don't know the C. So how can I find the C? This depends on this statement already, passes through R. Because what is R? R, it just means 0, C, right? So C is 7. So I simply just sub now. So this is 7, this is 0. So now I know what is my C already. So the equation of this line is y equal to 4 to third x plus 7. So 7 is so-called the y-intercept of the line. So that's how we solve this type of question. Okay? But overall, I think this question is a bit more tough. Right? So yeah, I hope this clear things up.